Welcome to Module 5 of LISP Your Mesh to Shape. This is the second part of the section we've called To Make a Mesh. Understanding the DXF code structure is absolutely necessary to successfully manage mesh entities through AutoLISP. We shall now study a data structure designed to be used as argument for mesh creating functions based on the endMake AutoLISP function. This data structure will be made up from three lists: vertices, faces, and edges, which will be the three arguments for a mesh making function. The vertices list will contain the coordinates for each vertex. The faces list is made up of sublists, each of them indicating the vertices that surround a face. The vertices are specified by indices that refer to the vertices list. The edges list will hold a sequence of pairs of vertex indices. Each pair indicates the starting and ending point of an edge. These three lists are the arguments which will be used in the end-mesh function designed to create a mesh through endMake. This function begins by creating the header with fixed values. The smoothing level, group code 91, is set to 0. The vertices are then added using the cons function in a for each loop to a list assigned to the variable end-list. Adding the faces data is somewhat more involved, is also done in a for each loop. A detailed explanation can be found in the handout. The edges information is added following a similar procedure. Although no information will be added for creases, the number of creases must also be added to the list assigned to the end-list variable. The header is then appended to the reversed end-list. endMake is then called with the final end-list as argument. AutoCAD doesn't have a tetrahedron mesh primitive. Using the end-mesh function, we can define a new tetrahedron command that will draw this polyhedron with a user-defined radius. It will be centered on the coordinate system's origin to make it simple. In my book, it is shown how to place it anywhere and align to any user-defined coordinate system. The AU 2012-mesh LISP code file includes three new AutoCAD commands that will create tetrahedrons, hexahedrons, and dodecahedrons using the end-mesh function. The only difference between them is the content of the vertices, faces, and edges lists. I'll try to show how this works by setting a breakpoint and opening the watch window. We'll then call the tetrahedron command from the AutoCAD graphic window. Now, by clicking on the Step Into button, we will evaluate one by one each of the expressions in the program. The returned values will appear in the watch window. When the ent-mesh function is evaluated, step into will enter its code. We can see here how the vertices are sequentially processed in a for each expression. List values can be easily inspected by double-clicking the Watch window. This will open an Inspect window displaying the list items. We will now follow the faces list processing, which is done in a double-nested for each loop. The external loop traverses the faces, and for each face, the internal loop processes its vertices indices, creating the code 90 sublist. Let's inspect the values added to the list up to now. Now it's time to process the edges data, also in a for each loop. A code 94 is previously added with the number of edges, which is half of the edges list length. And finally, the crease data, which is included as a code 95 sublist with the same value as the previous code 94. Once again, we'll inspect our list to which the header was added in this last expression. We can see it's ready now for passing it to endMake. Now we return to our tetrahedron command, where the mesh will now be scaled to the user-specified radius and the point of view and visual style will be set. The visual style system variables are set one by one to achieve our custom visual style and projection mode. This way we have created a perfect tetrahedral mesh using our newly defined AutoCAD command. We can test how this mesh could be progressively smoothed to soften its edges. The new hexahedron and dodecahedron commands work the same way. Up to now, we have shown how mesh objects can be created from AutoLISP programs. We've seen they can be created by calling several AutoCAD commands and without limitations as to their shape, through the endMake AutoLisp function. Our next modules will be devoted to modifying mesh geometry, that is, shaping a map.